Right. I had a few people absent in the first period, so I'm going to record the notes for them. I recorded them in the first period, but then I messed it up, so like I deleted the file. Right. Okay, so remember that next week, right? So I'll see you Tuesday and Thursday next week. That on Tuesday, you're going to do part 1 of your test for this chapter with the partner, all right? AP classroom questions, all right? And then we'll take the whole class, but like I'll give you like an hour to do it or whatever. But like the first half hour, we'll go over the homework and have a couple other things to show you or whatever. Anyway, then on Thursday, we'll have the second part, and that'll be like, free response stuff, like, stuff I'm gonna like, written things, like not multiple choice is what I'm saying. So the second part's not multiple choice. And I'll have to see how it goes when I make it, but like, maybe like one side of the paper is like, you can work with your partner, and then the other side by yourself or something like that, or I don't know, we'll see. All right. Okay. So if you're absent, you just have to come after school and do it by yourself. So you can test or whatever. Sorry. Unless someone else is absent and they happen to show up with you at the same time, that would be okay. All right. So semi-log plots here. So you already know, basically, this whole first part here, you know about semi-log plots because we talked about them along the way throughout the chapter. So the main thing to know about a semi-log plot, and if you're doing it on Desmos, there's that little button in the little button to do to make a semi-log plot. If you put in your table, you go over here to the wrench, you go to more options, and then you make your y-axis logarithmic, and then you get those little lines. Everything myself these days. All right. So anyway, that's how you can see the stuff on there. But what you're doing when you do a semi-log plot is you're changing the y value to the log of the y value. All right. So when you have data, and so this data on the left-hand side, what kind of function do you think would fit this data? Like, what does it look like to you? It looks like exponential. And the problem with it, though, is that the scale here, like the x-axis has, normal scale, like, okay, but the y-axis, these are huge numbers. So like 1 million. So if you have like 100,000 people, you're like, that's a lot of people. But if I have to graph 100,000 on a graph that's 1 million, it's like so close. It looks like it's 0. You see what I'm saying? So all these numbers, like this is a lot of people, but like it's so tight down here. All these points, all those points, they kind of basically look like 0 in a way. And so it's annoying because all of these, like all these right here, they look like 0 or like really tiny. But then if you change this to log, like a semi-log plot, so if you make these into logs, if you do the log of these numbers, it spreads them out a little bit better. And I'm like, oh, look, these actually are like pretty high up, and these kind of look ugly here, but like they're pretty high up. They kind of match all the rest of them, like in a slope type of way. So an exponential function or an exponential like pattern looks like what on a semi-log plot? Looks like a line. It looks linear. And so that's just the main idea. So if somebody's asking you, they give you exponential data, and they do a semi-log plot, it's supposed to look like a line. Okay? Now, 2 things about that. You know how exponential? It has a rate of growth. So when you have a rate of growth, what's a rate of growth on a line? Which part of the line equation is the rate of growth? The slope, right? So the rate of growth over here is the slope over here. And then the initial value. Your initial value on an exponential function is what's the initial value on a line? The y-intercept, all right, the b value. So this equation of this line, y equals mx plus b, the b value has something to do with the initial value over here, like a, b to the x has something to do with a, and the rate of growth, the slope, has something to do with the b value over here. Like that'll come out in the last example.
So if it's B is
M is, yeah, kind of, but like not exactly. But you'll see in the last example. I'm just saying they have something to do with each other. All right, but you didn't see. All right. So anyway, so let's look down here. So it says Mr. Passwater tells another one of his hilarious math jokes. It begins to spread around the school. The number of people that have heard the joke after a certain number of minutes is graphed on the semi-log plot here. Okay. So what you are seeing on the semi-log plot is that you're seeing a line. Okay, so that means if you see a line there, that means that the original data must have been not linear, but exponential. The original data was exponential. So that's what you're being asked for down here. You're saying to yourself, oh, well, what's the function that was really for the data, the p, the people that have heard the joke? All right, so look at these problems. Which one's even exponential? There's a couple of them. All right, the b and t. So you can see how this is not exponential. This is not exponential. Right, exponential like a times b to the x. So then I'm like, okay, well, great. Those are both exponential. Like I don't know what to do. But look, these points, they have to like make this thing true. So let's think about some of these points. What point would you think this one was? Is that 0? So 0 what? Yes, remember, you start at 1 and you go by 1. So that's 0, 2. What would this guy be right there? All right, so careful. I think it's 1 and 4. Because this is 1, and we go 2, 3, 4. So 4, 1 and 4. So these points have to make the problem true. So if I plug in 0, I have to get 2. So let's try it. If you put a 0 right there, so 2 to the 0 is 1, and 1 plus 2 is 3. That doesn't seem right. So let's start over here. 2 to the 0 is 1, and 1 times 2 is 2. That seems good. Let's try 1. 2 to the 1 is 2. 2 times 2 is 4. Right, so okay, so that's just the general idea on that one. So let's look here. So when you're doing a semi-log plot, it's important to notice you're not changing the y values, right? They're going to look differently, but you're not changing them. When you do a semi-log plot, what you're doing is you are graphing, like a semi-log plot, it's graphing the log of the y values. So your y value is now the log of the y value. So that's what you're doing on the y-axis. The x values are staying the same. So this data right here, do you see how it looks like exponential a little bit? Do you see how it's like it's going up so close? So so close. Now 2/3. I know it's not. It's close to 2/3, but if it was going by 2/3, it would be getting smaller. Right? So it's 3/2 is what it is. But anyway, all right. You see it's increasing, but you can't quite tell. You're like, I don't know. What the hell is this doing? Like 40, 60, 90. I feel like it's some kind of multiplying thing, but what is it? So think back to your geometric stuff. All right. If you wanted to figure out what's happening, you could say, what's 60 divided by 40? You could divide the two of them to see what you're multiplying by. So that would become 6 over 4, and then what's 6 over 4? 3 over 2. Uh-oh. Hang on. Where is my recorder? Hang on a second. Make sure I didn't lose it. Where is he? All right, he's recording. Sorry. Make sure. I'm like, no. All right. So, and let's just do another one just to see. So if I also take like 90 divided by 60, so if I do 90 divided by 60, it should be the same thing. So that would turn into 9 over 6, which is 3 over 2. Okay? So you see how this is multiplying by 3 over 2, about. Now, it starts to like get messed up a little bit. Like I don't feel like, you know, 90 or 135 times 3 halves is 203. So it starts to mess up a little bit, but the beginning is going pretty well. So it's exponential, it's a scatter plot. Okay. All right. So let's look at these things right here. So this table above, it gives us an exponential data. If I graph this on a semi-log plot, I should see a line. So can you look at those four and tell me which ones? They're not even lines, like it's so wrong. So which ones aren't lines at all? So I mean, B looks kind of like a line. We'll talk about that. So yeah, look, C is curved. It's like you're just graphing the exponential data, all right? So not C, that's not a semi-log plot. All right. Also, like look at the scale over here. It's not those weird like lines get closer together. So it's not the right like scaling. This one's also curvy, and also like the numbering system on the y-axis is not a semi-log plot. Right? So not that one. All right. So letter B and D, they have the right numbering system because look, this is 1, 2, 3, 4. It's fine, but like this is not correct. Like if I try to go to this point right here, what's that point right there? That's the point 3, 2. That's not what that said up there. Okay? But this one. So what would this point right here be? Be 2, be 10, 20, 30, 40, 50, 60. Right? Is that what it was? Yes. 2 and 60. Right? So this is the one. It has the right scale on the side. It has the right points. So letter D, like everything about it looks good. All right, so why don't you take a minute and see if you remember how to graph these points. So graph these yourself and then look up here when you're done. See if you got them right. Make sure I get them right. All right, look up there when you're done. Make sure you got them right.
Oh, no, wait, what?
Make sure I mess up. Okay, well, the x-axis is already 1. This would be 2. So you're between 1 and 2. Right? Because this line right here is a 2 line. Bessie, you're gonna pick it? Alright, we good? Everybody okay? 1.5 is a little bit weird, but yeah. Remember, that next line is a 2 line. Okay, alright, so that pretty much encompasses, like you kind of already knew that stuff, like a little bit. So, on this last part, we're dealing with the same data, okay, and the same graph from before that we had in the multiple choice. Alright, but remember, what's graphed over here is the log of these numbers. Like the log of 40 is graphed right there. Like that's what that's supposed to mean. Okay? Alright. So, but I still see it as, 1 and 40 and stuff like that. Because 10 to the 1 is 10, so this is 10. This is your hundreds. This is your thousand. That's what those are. Alright. So, now, let's think about this. I want to come up with an equation for a line for this data. So when you have an equation of a line on your model, you got 2 things that you need. Y equals mx plus b. You need this m and this b. What's the m? The slope. And the b is the y-intercept. So the y-intercept is the starting value. It'd be nice if I had a starting value, but I don't have a point over here on the y-axis, so I got nothing. So I could probably try to estimate it, but we'll find it a different way. Okay, so my slope. When I'm going to go calculate a slope, remember it's the change in y over the change in x, right? Like delta y, delta x. Remember good? Okay, so usually what I would do is I would just pick 2 points. Okay, so if I pick 2 points, so I'm just going to pick these 2 points right here. I'm going to do the change in y over the change in x. Now, when I use the y values, remember, I have to use the log of them because I'm on a semi-log plot. So I don't just do 60 minus 40 on top. I do the log of 60 minus the log of 40 because this new graph is using the log of these numbers. But on the bottom, the x-axis is just normal. So the bottom, I just do 2 minus 1. Okay, good? Okay, all right. So 2 minus 1 is 1, so I get a 1 down here. But on top, since I have 60 and 40 and I have subtraction, if I have subtraction, what can I change it into? Division. So that's a log of 60 over 40. So that would be the log of 3 over 2. You recognize that 3 over 2? Remember that was the multiplier? Something. Okay. So this is equal to my slope. There's my slope. Okay. So that's my m. So let's write down what we know so far. So I know that I have y equals, my slope is log of 3/2 x, like that's my x, and then plus b. So like this is where I am right now. So I don't have a y-intercept up there to work with. So do you remember back in Algebra 1? If you knew the slope and you have a bunch of points, can I just use one of these points and then figure out what b is? All right, so what do you want to use? The 1 and the 40 or the 2 and the 60? 1 and 40? All right, so let's use the 1 and the 40. So if I'm going to use the 1 and the 40 is the y value. Remember, it's not the real y value. I have to use log of 40. So if I use the 1 and the 40, I would say log of 40 equals, and now I have the log of my 3/2 times x. What am I pretending x is? 1 plus b. So now I can solve for b, right? Because the 1's not going to matter. So basically, if I want to solve for b, I have b equals, is it okay if I write log of 40 minus log of 3/2? Just going to subtract that over. So log of 40 minus log of 3/2. Okay. Hey, guess what? Subtraction turns into division. So I got log of 40 divided by 3/2. So let's figure that out a little bit. So 40 divided by 3/2 is times 2/3. So what would that mean? What's that? What's that? Come on, hurry up. Okay. 80 over 3, right? All right, so 80 over 3. All right, so there we go. I have my slope. I have my y-intercept. It says y-intercept. All right, so I'm going to write it right here because I kind of used up all my space. But the equation of my line is y equals log of 3/2 x, so that's my slope, plus log of 80 over 3. All right, so now, this last little part, it'll be pretty simple, but we're trying to figure out y equals a times b to the x. I want to know what a and b were, okay? So if you have the equation of that line, the a, remember that's your initial value. Which of these things, the slope or the y-intercept, which of them is your initial value? The y-intercept. So I'm telling you that the initial value is log of 80 over 3. So basically what's going to happen is my initial value here, I don't want the log part anymore. I just want the number. I want the log to go away. I don't want to take the log part. So that part is going to be the 80 over 3. So I'm trying to get rid of the log. So you take that log off, and that will be your initial value. And this part, that's your slope. That's your rate of change. So your slope over there is log of 3 over 2. So for us, that's going to be 3 over 2. So the slope turns into this. So what we're saying right here is we're taking it back out. So that log of 3/2, never mind. I'll just, all right, so here we go. So we're saying that our equation is about 80 over 3 times b is 3/2 to the x. So we're saying that that's our equation. And our last thing to check, let's go ahead and check it. Can you get your calculator out and put that data in there? Put that data in my calculator, and let's do a regression and see if it comes out good. I think I cleared my calculator, so I don't have it. Oh.
No.
Can somebody come put it in for me?
Good on my calculator.
Here, Kate will do it. Sleeping. Paper. That's paper. Way up. So use this one. And put that down in the calculator. All right, you guys do it when you did it right.
Sounds like it has the 2 in it.
Hell no, I want you to do it up here.
I told you it had a 2 in it. I told you it had a 2 in it. I was so, I looked that up. It's not.
So right now, don't take all day.
It's. I didn't know how to work it.
It's 20. Oh, told you it had the 2 in it.
So the equation. So you have this slope.
The top is long. No. Yes. Oh shit. No, that's house I posted. That's house. That's not. Please. No, I didn't go away. I don't know how to do it. Sure.
Okay, so thank you, Rahel. So Rahel did an exponential regression like you did, right? He pressed the stat, he put that data in, and he ran an exponential regression. So look what happens. The A value is 1.5. I'm sorry, the B value is 1.5. Isn't that 3 over 2?
Yep.
Right? And do you remember how the last numbers were seemed a little bit off? So this is not exact, but it's pretty close. So like the 1.5 is a little bit off because it wasn't perfect, but also 26.6. Can you guys on your calculator, what's 80 divided by 3? 26.66666, right? And so it matches, okay? So if you were able to get it in this log form right here, this equation, this line, whatever you have the log of, that is your increase, your rate of increase or decrease, and your y-intercept is your initial value. Okay? All right, that is it. Alright, so over here, here's your homework. It's a little bit long because there's pictures, and then take a plastic. But you do it, it'll probably be done in like 15 minutes. Same page.
I'm gonna take a picture. It's off. Turn it off. No, I know what you're doing. Not